In this lesson, we're going to talk about composite and inverse functions. So we've learned about functions. Functions are a key component of algebra. And functions combine operations like addition and subtraction, multiplication, and sometimes we want to take one function and connect it with another function. And we can do that. So functions can be added, multiplied themselves. Now we're also going to see how we can use something called a composition of functions, which is when we put one function inside of another. So let's kind of warm up here. Here's a few problems. If you want to try them on your own, you can pause and try that out there. So we've got a function given to us, f of x equals x squared plus 3x, and we want to find the following functions. Remember, this number inside the parentheses is what we're putting into the function. So if I want to find f of 5, don't need to write it again, I guess it's already there, we're going to put 5 inside of x. And so it's a good habit, even though in this particular one we might not need to, but it's a good habit to write it out. Everywhere there's an x, we're going to replace it with, in this case, 5. And we get 25 plus 15, which is 40. Great. Not too tough. Well, what if we plug in -5? So -5 is our input now. So again here, because of the negative, parentheses are real important there, all right? So -5 squared, 25, and then minus 15, because this is going to be a -15, right? And so that is a 10. There you got it. Okay. Well, what if we put a 3a in there? So, okay, this is kind of weird, putting a variable inside of it. Well, we can do that. 3a squared plus 3 times 3a. Well, 3a squared is going to be square the 3, that's 9. Square the a, don't forget to square both of these here. And we get 9a squared. Plus, the second one here, 3 times 3 is 9a. That's it. You can't do anything with it. We can't combine those. One's squared, one's not. You can't combine unlike terms. All right. So how about 3 plus a? Well, all right, getting even more strange here. We've got, the function here. The function says take the input and square it, and then add 3 times the input. So when we're doing this, we're going to find it really useful to take that, and instead of writing it with x's, let's write it with these empty blanks. See how this is saying the same thing here? X squared plus 3x. Well, that's input squared plus 3 times the input. Well, now I'm going to go ahead and fill in that blank there with 3 plus 8. 3 plus 8. I'm putting that everywhere that the x was, all right, because x is the input. And now I can clean it up. All right, we know how to square this, right? Think about a plus b squared. We square the first, 9. Square the last, a squared. And then this middle term is 3 times a doubled. 3 times a doubled is going to be 6a. And then here we'll just distribute 9 plus 3a. If you want to write out the 3 plus a times 3 plus a, go ahead. But hopefully we're kind of moving away from that. We got 9 plus 9 is 18. We've got 6a plus 3a. That's going to be 9a. And we've got a squared. All right. And there it is. Now we might want to write it in descending order. A squared plus 9a plus 16, not always necessary. But there you have it. Can't do anything without it, or with it, I should say. All right, there it is. So what we just did was we took a function, in this case our f of x that we defined, and we started putting numbers in it, but then we started putting other things into it, like 3a, 3 plus a. And these are like little functions. So what we're doing here is what we call a composition of functions, okay? Now, let's think about something here first for a moment before we get into the mathematical composition here. One good real-life example of a composition of functions is a machine like this saw right here, reciprocating saw. Real useful saw, real handy, can cut through all kinds of stuff. Even this guy can work a reciprocating saw. So a reciprocating saw has a saw that goes back and forth and cuts through walls and stuff like that. So anyways, now if we break apart a reciprocating saw, we take that brand new saw, we pull it apart, we'd see something like this. Now, there's all kinds of parts that have different properties here, that have different jobs. There's this part, which is a motor, standard motor, all right? So this motor spins. Okay, so its job is to spin in circles, but we need the saw blade to go back and forth this way. Well, we have another tool, or another part, I should say. There's this part here that obviously somebody very creatively invented that takes this circular motion here and change it into a back and forth motion, all right? So here we have one function that we put into another function and creates another outcome, all right? So this, that's kind of an example of a composite function. All right, well, let's look at a mathematical example of a composite function, all right? So I've decided to open up a coffee stand. I'm going to call it Simply Lattes, all right? That's all we make because I like lattes, so everyone else should, right? So I'm going to charge, make this simple. I'm going to charge $2.50 per latte, all right? My overhead, how much I got to pay for my little coffee stand, is going to be $175 per day. And with materials and coffee and milk and stuff like that, it cost me 75 cents to make the cup, all right? Well, doing some calculations here for my little business, I can figure out that my revenue, my income, is going to be 2.5 times N, if N is the number of cups that I sell in a day, all right? So N is going to be the number of lattes sold, all right? And then my cost, well, my cost is going to be 0.75 N plus 175, all right? After I've been open a little while, I realized that when it's colder outside, I sell more lattes. All right, when it's hot outside, because I'm only selling hot lattes, let's say, then I don't sell as many. So I got this function that I came up with. The number is a function of the temperature. The number of lattes is a function of temperature. And it's about 240 minus 2T. So if we got our temperature in Fahrenheit, that will give me the number of lattes. So if I know the high temperature for the day, I can predict the number of lattes I sell. Okay, so let's make some new functions for revenue and for cost in terms of T. Well, my revenue was 2.5 times N. Well, if N is 240 times or minus 2T, I'm going to put that in place of N, and I get this new function, 2.5 times that, 240 minus 2T. Maybe I'll distribute this here. And so my revenue as a function of T is going to be 600 minus 5T. All right. So if I want to figure out my revenue, I can just know the temperature and plug it into this equation. I got my revenue. If I want to figure out how much I'm going to be spending, well, my cost was this guy right here. Okay. So I can plug this new expression into my cost, and I'll get a cost function, okay? So a cost is going to be, I'm going to take 0.75 times 240 minus 2T, because that's how I figure out what N is, plus 175, all right? So, all right, we can distribute this here. We're going to get C of T, and this is 3/4, so that's 180 minus 1.5 T plus 175. All right. And combining like terms there, we get our function, C of T, and that is equal to, add these up, I think that's 355. minus 1.5t. Okay, so we got a function for the revenue with money coming in and the function for the cost. So if we want to find the profit, well, we got to subtract those. So profit we can use by combining those two things, our revenue minus our cost. All right, so our profit is going to be the revenue, which is 600 minus 5t, minus the cost, which is 355 minus 1.5t. Now we just clean that up and we got our profit function. Okay, so the first parentheses can go away because there's nothing in front. Okay, here we got to kind of distribute this negative minus 355 plus 1.5t. Combine like terms, 245 minus 5t, that's minus 3.5t. Okay. All right. So there we have it. Okay. And so this is supposedly is an equation that if I wake up in the morning and I check the temperature on my weather app, I can know exactly how much profit I'm going to have at the end of the day. All right. Well, maybe kind of a silly example, but this is how we can use a composition of composite functions, meaning we're going to put one function for n inside of these other functions, and we get new equations that can be useful to us. Just like in the reciprocating saw, we can put a circular motor into this tool, and it produces a new type of motion, this back and forth motion, that makes the saw work. So that's what a composition means. The way we write a composition of function in algebra is we can write it with this little open dot here. This means f of g, or f composed with g. And another way of writing this is f of g of x, all right? We read that as f of g of x. So we can put g inside of f. That's what this means, okay? So the domain here, we got to make sure that x actually works in g, and then we got to make sure that the output of g is in f, all right? So just got to watch out for that. So let's try some compositions here, okay? So here we've got two functions that are defined. We've got f of g, and we've got, f of x, and we've got g of x, all right? And so we want to put one inside the other. Well, first thing here we got is f of g of 2. Well, every time you have this, it's a good idea to rewrite this as f is the outside function of, and we're going to put g of x inside, or more specifically, g of 2, okay? All right, f of g of 2, that's what's going on. Well, the way to do that is we want to, when we have a number, now notice here we got a number, not an x. In just a moment here, we'll have one with an x, but right now we got a number. Well, we can go figure out what g of 2 is. What is g of 2? In this case, g of 2 is 2 squared plus 4, which is 4 plus 4, which is 8. So g of 2 is just 8. So now we can replace this g of 2 with 8, and we see that f of g of 2 is just f of 8, which is 2 times 8 plus 5, according to our definition here. And that is 16 plus 5, which is 23. Okay, see how that works? If we have g of f of 2, well, now we're going to reverse it. So g is being composed with f of 2. Now again, because we have a 2 here, not just a variable x like we'll have in a moment, we can go ahead and figure out what is f of 2. Well, let's figure that out. F of 2 is 2 times 2 minus 5, which is 4 minus 5, which is negative 1. So that means we have g of, we're going to put this negative 1 in place of f of negative 2, and we get g of negative 1, because f of 2 is negative 1. Now we look at g. G is this function. It's defined like this. And so we say, well, if we put negative 1 into there, we get negative 1 squared plus 4. Okay? So that's if we have a number in the domain there, 2 in this case. What if we have just f of g of x? Well, this means we're going to have an x in our answer. So we're going to have a general answer, kind of like we did with the formulas on the previous page there, with the lattes. So f composed with g of x. So again, the best way to go here, I would strongly recommend, is rewrite it. Most people are more comfortable with it in this way. These are equivalent. This just means we're putting g inside of f. You can see that if you write it out like this. Well, what is f? F is 2 times x minus 8, or 2 times the input minus, 5. I said 8, meant 5. 2 times the input minus 5. All right, so we have 2 times the input minus 5. So when you write this out, let's write the function out and just leave a blank where the x is. Because what is going into f? Right now we're putting g into f. So we're going to put g into f. Well, what is g of x? G of x is equal to this. So we're going to swap out g of x for x squared plus 4. So we took f, the red thing, and we put the blue g into f. And now we can just clean it up, and we've got a new function. Okay, so if we distribute here, we're going to distribute the 2 times x squared plus 4 minus 5, which is 2x squared minus 1. There it is. So there's our new function, f composed with g. Let's try the other way around. If we go g composed with f, that means we're going to put f inside of g. Again, it's a good idea to rewrite it like this. G of f of x. Well, what is g? G is x squared plus 4. So we're going to take x squared plus 4, but let's write it as blank squared plus 4. What is going on in the inputs here? What is going into the input? Well, f of x is going into the input. What is f of x? Let's look up here. F of x is 2x minus 5. So 2x minus 5 is going into the g function. That is the input. And now we just want to clean that up. Okay, so we got two functions. We're going to blend them together. Got our red function, our blue function, makes our purple function here, okay? How do we square this? You can write it out if you want, or you can use our rule, our shortcut. Square the first thing, we get 4x squared. Square negative 5, we get 25. Multiply them, you get negative 10x. Double that, we get negative 20x. Okay, that's using a minus b squared equals a squared minus 2ab plus b squared. And then don't forget this 4. So in the end, we've got 4x squared minus 20x plus 25, actually 29, because 25 plus 4. That's the idea. So we take one function, put it inside the other, and clean it up. All right? We can also, we'll run into some table problems here. So here's a table with some x values, not every x value, but some. And then some definition of what f is. So f of negative 4 is negative 6. F of negative 3 is negative 4. So on and so forth. G is defined like this. G of negative 4 is 15. If you put negative 3 into g, you get 10. If you put negative 2 into g, you get 5, and so on and so forth. All right? So we want to find out what these are. G of f of negative 3. Well, let's write that out. That means we want g of f of negative 3. Okay? I think I changed my colors around there. So f of negative 3, we're going to take negative 3, put into f. What do we get? We get negative 4. So that means we have g of negative 4. Well, what is g of negative 4? Now we can look at our function. G of negative 4 is 15. All right, so 15 is the answer. All right, for the next one, we got to fix this a little bit here. Let's add these values. When x is 5, f of x is 12, g of x is negative 12. All right, going to need that. And let's go ahead and try, instead of negative 3 here, we're going to try 2. All right, the table wasn't quite set up for that, so we'll fix it. Okay, I'm breaking the rules here. That's part of being the teacher, right? All right, so what is f of g of negative 2? All right. Well, that means we've got f composed with g of negative 2, f of g of negative 2. Well, what is g of negative 2? G of negative 2 is 5. All right, so we're going to take that g of negative 2 and replace it with 5. And then that's going to give us... Oh, what is f of 5? Well, look. Oh, f of 5 is 12. Good thing we wrote that in there, right? Okay. That's the idea. All right. So when we're finding this compositions, when we have numbers working from the inside out, when we're composing with expressions or equations, put one equation or expression inside of the other one.